Welcome everyone. I'm Otai, team lead, joined by Aaron, our tech lead, and Prima. Our project is early risk detection for mental health issues using machine learning. Let's dive in. Here's our quick roadmap for today. We begin with introduction and goal to set the stage. Then we move to the dataset overview and analysis. Next, we walk through the model approach and the criteria for model selection. After that, we outline the results at high level. We'll wrap with future efforts and close with a live demonstration. Mental health struggles are widespread yet often missed. So many people do not get help until crisis. The World Health Organization estimates depression affects more than 280 million people worldwide. Our goal is to build a trustworthy, data-driven risk screener that flags low, moderate, or high risk early so support reaches people sooner. Designed for schools and workplaces, it augments counselors and wellness teams, protects privacy and consent, and guides timely follow-up. It's not a replacement for clinical judgment. Our source is from Kaggle. The dataset contains about 300,000 anonymized survey responses with 17 features. It includes demographics, stress level, work information, and coping indicators. We use this data to stimulate real-world survey scenarios, giving us a realistic foundation for the screening workflow. Examining the data set, here's one example from our exploratory analysis. Gender distribution by country. Most responses come from the United States, followed by the United Kingdom and Canada, with a long tail of smaller contributors. In most countries, male respondents outnumber female. The takeaway: countries has many distinct categories with uneven representation, and this demographic skew can bias models if left unaddressed. These insights will shape how we prepare features and split to achieve accurate, fair predictions. Now Aaron will walk through the datasets, cleaning, and preprocessing.
Thank you, Ty. So now going to the data cleaning and pre-processing, first thing we did was remove missing values, duplicates, or underrepresentation within the countries. After that, we had category encoding and formatting. And the big thing I want to highlight here is generating the risk label for the by doing K-mode clustering. What we did was essentially use an unsupervised learning method where it used the data and got the modes of all the columns and created the different columns where it was low, medium, high of what the risk would be off of the data it's given. From that, we also dropped the prominent features that was used within the risk label so that way we don't have the AI that we're creating basically reverse engineer that. So looking at the data deeper into it, if you look on the right side first, you'll see the top five that we kind of removed. Occupation, days indoors, care options, change habits, and social weaknesses. We kind of went for a social aspect realistically of what we wanted to remove. These were very prominent in actually creating that K-mode cluster. So we decided to take those out. And then the other part that I do want to show is the gender, self-employed, and mental health interview we took out because they just didn't add anything overall. And this is what's going to drag me over to the left side where you see the chi-squared statistics for each feature. Basically, these are the features we ended up with at the end. Um, as you could tell, those last three that we did take out, they didn't really do much, so we did remove them, and then which led us to have the other couple that we still have there, showing that family history, treatment, and coping struggles are what's kind of gonna be driving this model essentially, and different things to go from there that can get us that risk label. Now into like the model approach after we know how the data is, creating our actual target variable and taking away the features that could hurt because of that target variable we created. We tested three models, which was a logistic regression to get at a transparent baseline, a tabular neural network which understands complex patterns and is also really good for tabular data in the sense of if you have multiple features. Initially when we were starting this, we expected to have like about 20-ish features, 20 to 30 features. Obviously after we did the clustering, we had less, but still, it was good to experiment with. And then the last thing we did was a self-voting ensemble, which was more experimental on our side, just wanting us to see how an ensemble model would work. So finally, we get to the model selection, the one where we actually honed in and what's going to give us the best results, which was tabular neural network. We looked at creating the dense layer batch norms, GLUs, and attention maps. This is that way we could get the different perspective of the different features. If you look on the right side, that basically shows the TabNet block. and this is basically how it does its prediction, or at least part of its prediction. It does this a couple of times. Ours was a three-step, which means it does it three times. We'll get different perspectives because within each block it is focusing on perspectives it hasn't looked at before. We'll aggregate them together and finally give us the AI output overall. Some other additional stuff that we did do was a 730 split, just that way we have balance on training and test data. It was 20 iterations, and there was early stopping to make sure there wasn't any overfitting.
Thank you, Erin. So our evaluation compared three models: logistic regression, soft voting model, and the TabNet inspired neural network. TabNet achieved the highest performance across almost all metrics, with accuracy at 79% and ROC AUC scores above 94% for all classes, showing excellent ability to separate mental health risk levels. Logistic regression, while simple and highly interpretable, scored lower with ROC AUC around 83-85%, particularly in class 0 and class 1. The soft voting model offered the best balance across classes, but slightly trailed TabNet in pure performance. So as far as the limitations, ethical, and the future work, our data set is survey based, so responses may have self-reporting bias and demographic underrepresentation. Any AI assisted mental health risk prediction must be complementary to professional evaluation, not a standalone diagnosis. Privacy and ethical compliance, especially with the HIPAA standards, remain critical before deployment. As far as the future work, expand the tool to include LLM-based explanations for better interpretability. Conduct real-world pilot testing in healthcare and educational settings. Implement regular bias audits and integrate expert feedback loops to refine accuracy and trustworthiness. Now moving on to the live demo. This is our final Gradio-based user interface connected directly to our best performing model, the Tabular Neural Network. So this UI simulates how a healthcare provider might interact with the screening tool to assess mental health risk based on user input. Each of these drop-down and radio buttons represents one of a self-reported features such as occupation, stress levels, mental health history, and social support, exactly matching the features used during training. This ensures schema consistency within the model. So once the user submits their input, the backend converts it into a structured data frame, applies the same encoding logic used during our training, and feeds it into the TNN model. The model then returns a risk classification like low, medium, or high, and a tailored recommendation. So I'm going to run the live Gradio interface, and you see it here. So I'm going to choose the mental health condition. The daily activity is somewhat low, the stress level with slight increase, mood swing, yes, challenges, receiving treatment, yes, and family history, yes, and female. And then by clicking the assess my risk, this instantly see the predicted risk category and suggested next steps. Here's the user instantly see their predicted risk category. This emulates what a doctor or mental health professional might use during an initial assessment. I'm going to use a different one. So for now, very low and no increase. Mood swings, no, and here is no and no. And then I'm going to just assess my risk. And you see it gives a different risk level as moderate risk. This UI is lightweight, fast, and deployable in platforms like Hugging Face Spaces or any cloud environment for real-time mental health screening. Thank you.